One of the places where exponential numbers and methods gets used a lot is in calculating growth. When we have a population, it grows depending on how many there are already. The more there are, the faster it's going to grow. And that gets modeled very nicely with the following formula. The amount at a given time t is equal to some initial amount times e raised to the kt power. And we just have to let k be positive. As long as k is positive, this will be a growth problem. Turns out if our exponent is negative, then it's a decay rather than a growth, but it still works the same. It's just a matter of what the sign in the exponent is that determines that this is growth. And notice again that we're using Euler's number here because it's just a natural fit for what we're trying to do. So we're going to use Euler's number quite a bit. So we're going to look at a particular problem. We're going to look at the human growth, human population in the world. And in the year 2000, the human population in the world was approximately 6.08 billion. So that's an important number. Assume that the annual rate of growth from 1990 onwards has been 1.6%. Using the exponential growth model, notice I gave it here, estimate the population of the world in the years 2030 and 1990. Well, our model, based in the year 2000, so t is based on 2000, so that if I wanted 2010, then t would 10 implies that it's the year 2010. So because we're using that 2000, our rate, or our k value, is 1.6%, or 0.016, and our initial population, a naught, is the 6.08 billion. So all we need to do for part A is to recognize that t is 30, because it's 2030. So a of 30 is equal to 6.08 times e to the 0.16 times 30. So we get out our calculator now. 6.08 times, I'm going to do a parenthesis, 0.016 times 30. I'm going to close that parenthesis and then raise it to the e to that power and then times. So when I hit equal, this will tell me what my population will be. And it says in the year 2030 we should be at 9.83, approximately 9.83 billion people. Well, we can also do 1990, in which case t is negative 10. So a of negative 10 equals 6.08 times e to the 0.16 times a negative 10, which is again going to be an approximation because we have to round it somewhere. 6.08 times, 0.016 times a negative 10, close the parentheses, raise it, equals. There are roughly 5.18 billion people in 1990 in the world. Notice that that doesn't take very much, and it grew very quickly, and it's only going to keep growing more and more quickly as we go farther and farther in time. But that's an example of exponential growth.